So continuing to the previous module, static analysis tools, using cryptographic hashes, how we can identify a particular malware as a malicious file with the help of the hashes of that file. So using cryptographic hashes, each and every file has its own signature, what we can call it as a MD5 signature or SHA signature, SHA-1 version signature, SHA-256 version signature, we can say. Right, each and every individual file, it has its own signature, own hashes. So how these hashes will be useful for analyzing, by doing a static analysis. Organize and identify the specific samples. If you want to store your samples, malware samples, you have to organize and identify a specific samples what you have been actually analyzing, and with the help of the hashes. Hash with multiple algorithms. You have to hash your malware samples with multiple algorithms, even though it has been already hashed, right? So get much resources from the online. So I am going to tell you what is mean by cryptographic hashes here in this slide. So you are seeing a picture here, right? So the left hand sided box is called actually a file, right? If I am passing it to an algorithm, say for example MD5 or SHA-256, it has been converted into a hash. This right-handed box with the purple color is a hash. So this is actually a fingerprint of a particular file. This is a fingerprint of a particular file. Again I am saying the left-hand side is actually a file. Whether I am passing this file towards an MD5, any hashing algorithm, it will convert it into a hash. So 6250 it starts with, right? So this is called actually the cryptographic hash of a particular file. The same file I am taking here in the below table, below box, where I am modifying the first bit of the file. Say for example the malware, the file first bit is actually 1. I am converting this 1 into 0 in my modified file. So I am passing the same modified file into the hashing algorithm. I am getting my different hash, which is completely different from the previous hash generated. So the thing is, if I am changing a single bit in my file, in any file, and I am passing the algorithm and I am getting my signature, it will be completely different from the previous file. So this may also, you can hear in the integrity principle, in the principles of security under integrity. So this cryptographic hashes will be useful for doing analysis by searching that hashes in Google search or some VirusTotal websites also. So I will give a demonstration of how to check the hashes in VirusTotal and all, right? So I am opening my VirtualBox, going to the malware samples. So in this malware samples, I am going to use my HashMy file. HashMy file is my tool where I have installed, where I have downloaded from the URL which I shown you earlier, and have downloaded here into my, copy it into my virtual machine and install it and creating my shortcut in my desktop, and I am dragging my infected.exe into this HashMy file. So it shows that this is my file name, and for this file name I am having my MD5. This is for this file I am having the MD5. This is the MD5, passing the MD5 algorithm, creating a MD5 hash. This is SHA-1, right? SHA-256 and SHA-512. So different kind of hashes I am having here. So with the help of this hash, I am right clicking and copy MD5 and going into my host OS, and I am going to do a Google search. So when I am Google searching here this hash file, it will show some results, right? From that results you can able to get some information. Actually it is showing it is a notepad.exe file. This MD5 belongs to a notepad.exe file, which means that we already have some 10 results, which means that this file has been already analyzed by some other malware analysts also, right? So this is how we can do a Google search also, and we can do a hash search in VirusTotal also, where we can copy this hash file into this VirusTotal website. We can fetch some results from the VirusTotal. I have already tell you what is mean by VirusTotal, which is actually having several antivirus engines that will scan the file or scan the hashes, and it will let us know the results of that particular file. So I am here clicking the search, and I am pasting my hash. So, and after clicking enter, it shows that most of the antivirus, none of the antivirus has been detected as a malware. So it might be a genuine file. It might be a genuine file, and it has been published by Microsoft corporations also. Maybe a genuine notepad file also, right? So let us actually let us get into an actual malware file. I think there is a malware file here. It is. So this is a malware file, right? I am opening my exe info p, dragging this file. So this doesn't have any extension. I don't know whether it is a document file, PDF file, or any exe file. I'm dragging here. Yeah, it shows that it is a 32-bit executable file. It is a 32-bit executable file in my exp info, and it is also not packed. You can go for OLE debug tool to unpack this, to see the strings in that file. That is a suggestion. And it is actually a Microsoft Visual compiled file. It's a Microsoft Visual compiled file. So we can see the P header also. I will let you know about the P header in a very detailed way in the next lab session, and the next module itself. So I will let you know. So we can have the P header, and one more thing is subsystem. In this subsystems, we came to know that it is actually a GUI format. It is in the GUI format. Some GUI will be there, some GUI mode will be there if I am executing this file. So I can and convert this file into rename this file into a .exe file. Since it is an executable file, I am confirming here with the help of this exp info. There is another tool called FileWrite. So I have installed the file also. For that I have to go for command prompt, and in this command prompt I have created that file shortcut here, I think. So it's there, yeah, file shortcut. I am dragging that thing, that shortcut here. I am calling that, which means that I am calling that file.exe, and I am giving space here, and I am dragging this file here, and I am clicking enter. Yeah, you can see here, right? It is actually a P32 executable file. So this is another tool. File is also another tool. FILE is a tool, a static analysis tool, which will tell you whether it is a executable file or not. So it says that it is a P32 executable file for MS Windows. It has been created for a particular OS, Windows OS, and it will be executed in a GUI mode also, right? So let us compute the hash of this file, right? Hash of this file. I'm opening my hash my tool, dragging this thing into here, right? I am right clicking, copy my MD5, going to my host system, right? And I'm searching the hash in the VirusTotal. Searching the whole hash in the VirusTotal. So, and also parallelly I'm doing some Google search also for that MD5, right? Yeah, actually Dr. Web antivirus, FMS antivirus is detecting is as a program unwanted file. One engine is detecting as a, and probably it might be a new sample what I have downloaded just a few hours back from virus resource. Unfortunately, my Google search is not showing any results. So VirusTotal is showing it might be a unwanted program. It might be a unwanted program, maybe a fake antivirus program, maybe a fake antivirus program which it is showing. right? So getting into my virtual machine. So, and also I can drag this file into the free hexaeditor tool also. So let us drag this file into my free hexaeditor. We can see the MZ, right? This program cannot be run in the DOS mode. Another string is there. It is a PE file. It is a PE file. Magic string is there, MZ, and this program cannot be run in the DOS. The same string is there for a portable executable file, and there is a PE string is also there. Hence it is actually a PE file. So I am also going to give a file for you for doing some exercise. You list out the indication of compromise, IOC, right? You give a full report for the lab manual by analyzing a particular malware, what I am going to give you in the next module. So you do a static analysis, basic static analysis. So basic static analysis means what you are going to identify here. So you are going to identify what kind of file is this. You can identify, right? It is a exe file. You can identify. It is actually a P file, right? MZ string is there. It is actually a P file, right? And while dragging it into the exe info tool also, it will open, right? It shows that it is a 32-bit executable, right? You can confirming that it has a GUI, Windows GUI, right? So you can derive this kind of informations by doing the static analysis, right? And computing the hash. When I am opening it in the hash my file, tool, I am dragging this exe file, virus file into this. I am getting my MD5, right? I'm deriving my MD5. Extracting my MD5. So copy MD5, and if I am doing some VirusTotal search and Google search, I can able to find out whether it is a malicious file or not. Previously in my MD5 search, it is actually a legitimate file, right? So this is where actually you have to do the static analysis. This is where you have to do the static analysis, right? So let us have a summary in this static analysis. Initially, we have seen this thing, right? So we have completed 3 sessions: introduction, malware analysis lab, introduction, setting up the malware analysis lab, and in the 4th sessions we have did some assessment, and finally in the 5th sessions we have configured the sandbox with malware analysis tools, mostly the static malware analysis tools. Now we are not dealt with the dynamic analysis tools, right? So we have seen the basic configurations, what we have to do in a virtual machine: host only network, drag and drop option, fake net installation, disabling the firewall and virus protection. So this is how we have to do a host only network. We have seen a demo. For a drag and drop option, we have seen a demo. For fake net simulator installation, we have seen a demo. And I have given the links, URLs, where you can download all the tools and all. You download it in the host file, host OS, and drag and copy it into the guest OS where you have installed your virtual machine, and you install all these tools and create a shortcut for each and every tools, right? So I have shown the static analysis objective. So we have seen what kind of file is this, is there any informations we get before executing that file, any embedded strings found, right? Is there any usual in PE header? So these 2 things, embedded strings and unusual in PE header, I will let you know in the next 2 modules, right? I'm going to do this in the separate module. What are all the embedded strings present in the malware, and also any unusual thing which is present in the PE header. So is it packed or not? We have seen, right? Is it packed or not? We have seen, right? It is not packed. We have seen 2 files, notepad.exe and some random hexadecimal characters.exe, right? So it is not packed. It is not. Both the files are not packed. If it is packed, If it is packed, it will be like this, right? It will be like this here. UPX is there, UPX, right? So this is the things we have seen. The first tool is we have seen the free hexa editor tool, where we have seen the basic strings, and then second one is exe info PE, where we can find out the subsystem whether it is a GUI, whether GUI will open when I am executing that malware. Please make aware, ensure that don't execute any files in your host system. Please do execute in your guest system, I mean in the virtual machine. Please execute. If you want to execute, you take a snapshot and execute, right? So please make sure. So, and then we have seen the cryptographic hashes also, what are all the hashes, and we have seen this hash search and the Google and VirusTotal. We have did a demo also. So here in this PPT I have shown some hash search with some results, right? Some results are there, so it is there, right? So this is how finding the hashes. We are having two tools, compute hash and hash my files. So with the help of hash my files, I have shown how to extract the MD5 of a particular file, right? So you will see some other tools, I mean static analysis tools that has been related to the embedded strings and unusual in PE header in the next module. Thank you all.